All right. Good morning, Team Impact. Getting started here. Good afternoon if you're in after lunch, I guess. I think I am going to utilize this video today. We just got done with converting the metric in the customary system. Remember, King Hector drives but doesn't crash much. So we are going to move on to student handout 4, and hopefully have enough time to do this. So anyway, Luca and Celine travel the same trail. Luca rides his bike while Celine walks. Use the data in the graph at the right to complete the multiple representation of this rate of speed. Okay. So across the x-axis, we have time in hours, and up the y, we have number of miles. Remember, this is the origin, the 0, right? So let's go here. So I'm going to start with Luca, since he's right here. Here's a 1, and where does 1 intersect? Oh, I get a nice intersection of that. So across the hours is 1, I get 8 miles. All right, and let's see, across 2, I get 16 miles. So clearly I can see what y equals. Remember, this is x and y. Y is going to equal 8x. Okay, so this would be 3, and this would be 24, and this would be 4, and this would be what? 32, right? I could have started with 0, 0. I didn't. Okay, so let's go to Celine. All right, again, this was our x coordinate, and this is our y coordinate, right? So Celine is right here, and I go to 1, but I can't get a good read there. You know, it looks like 3, but I'm kind of unsure. So if I go to 2, I get a good read. I get a good intersection point across the x and y axis right there. So really, I'm going to go with 1 here, but 2 there, and 3 here, and 4. All right, but I'm going to start with 2 because it's 2 and 6. If I go to 3, I don't get a good intersection, but if I go to 4, I do. And 4 is what? 4 and 12. Now, I'm going to go ahead and come down here and figure out what my equation is. How am I getting from x to y? Well, I'm multiplying it by 3, clearly, right? So y equals 3x. So now I'm just going to use my equation to fill in the ones that are empty. 3 times 1 is 3. 3 times 3 is 9. Okay? So having that equation just solves a lot of problems. Okay. The unit rate is the value of y at the point of 1 comma y, the ordered pair. Use the graph above. What is the unit rate at Luca travels? Okay, so I've already figured this out because here it is. It's 8 miles, right, per hour. Yeah, per hour, right? And then the same thing with if they want Celine. What's the unit rate for Celine? Well, it's 3 miles, right, per hour. And I took care of that because I started with it. You know, I take care of all my labor up top. I would take care of my equations. I take care of my unit rate. All right. And I labeled X and Y. You know, it just makes more sense to me to do it that way. How much further does Luca travel in 2 hours than Celine? After 15 hours, how many miles will Luca and each travel? Okay, so let's start with the first piece. How much further did Luca travel in 2 hours than Celine? Okay, well, it's 12 minus 6, right? It's 6 miles. That's how much further, right? Okay. Oh, I made a mistake. I was wondering what happened there. It's 16, sorry. It's 16 minus the 6, which is 10 miles. 10 miles. I don't know where I got the 12 from. Sorry about that. And then how many will each travel? Miles will they travel in 15 hours? Well, I can just use my formula, right? So I can say y equals 8 times 15, and y equals 3 times 15, right? And this would be what, 120 miles? And that would be for who? Luca. And this would be 3 times 15 is 45 miles. And that would be for Celine, right? Okay. I already wrote the equations up there. I took care of the business at the beginning. I'm going to change up my variables. Instead of using X and Y, I'm going to use their letters. So I'm going to say for Luca, I'm going to say M for miles, equals 8H. 8H. And Celine, I'm going to say for miles, M equals what? 3H. 3H. Okay? So really, this is the same as that. I just changed the variables, right? All right, we are rolling on. Good lesson here today. Veronica is looking for a bakery to buy cupcakes for a baby shower. She wrote equations to represent the price per cupcake. Okay, no problem, right? Orders taken from greatest to least per cost. Okay, so greatest to least. So when we look at this, we're just looking at the equation. What's going to be the most, right? Well, clearly it's June, right? June is charging $3.75 a cupcake, right? And then who? I think it's Lavender for him, right? Lavender. And then finally, Sugar. Sugar Love. Okay. So just looking at one of the factors in it in the equation. Let's flip it over. Okay. So on the next page, all right, we have a bunch of function tables, and they want unit rates. Unit rates. Some of them are given, like in the first one. The unit rate is given because the day is 1. Others are not. So we're just going to go ahead and divide it out. Okay. So the first one is 4,000 steps per 1 day. Right? Now on this one, okay, I'm going to grab my calculator here. And I'm going to take 5,000, and most of you know what this is. Divided by 2 is 2,500. So what? We get 2,500 steps per 1 day. Unit rate per unit, right? Ricky, same deal. Take 12,800, 12,800, and I divide that by 4 this time, and I end up with 3,200 steps per 1 day, right? And then finally, I have 9,450 divided by 3, and I get 3,150 steps per 1 day. Unit rate per day is the unit, right? Okay. Okay, we're doing okay so far. Hope so. Okay. More of the same. We just got to keep pounding these rates, ratios, and unit rates. Order the friends from least to greatest. Okay, no problem. Clearly 2,500. So Elias is first. And then we have what? Yuval. I just put a little check there. Ricky. And then Holly. Right? No problems. You know, just looking at the numbers. Once you get it in a unit rate, it's easy. It becomes very easy. Okay. Let's continue here. Good question here. Looks like we're looking for more unit rates. Terry observed a fast food drive-through window for 4 mornings. She wrote equations to represent the average minutes per customer ordering from each window. So the average was 5.5 minutes on Tuesday was 5, Wednesday was 4 2/5 and 6 minutes. Determine the unit rate for each of the 4 mornings and fill in the table below. Okay, well, this is really kind of tricky here, and they're actually just kind of giving it. Our unit rate is over 1. This is 1 because this times this would be this. So actually, this is just 5.5. The unit rate here is 5. The unit rate here is 4 2/5. There's nothing to divide. All we're looking at is the equation is 6. Those are your unit rates. And if you wanted to, you could put those over 1, certainly. Okay? Kind of a dumb question, but we have to answer it, right? Okay. Lastly, the unit rate is the value of y at the point 1 and y. Okay. Determine, right? So 1 and y. So if this would be x and this would be y, 1 would be there, all right? And y, whatever it is, right? Determine the unit rates of the equations below using the graphs. Okay. So what we're going to do is we're going to take one of the number out of the factor. It's going to be 2. Okay. Now, all right, it says determinant for 1 and y. Well, 1 is here. This is x. Y is here. So where's it going to intersect? Well, if we have this at 1 and y, all right, it's going to be 2. All right. So when we look at this, anyway, I had to cough there for a second. So if we took this and put it over 1, we have 1 and 2 right here, right? The next one, if we put 6 out of there and put it over 1, similar to this, right? And it says 1 and y, 1 and 1, 2, 3, 4, 5, 6. Okay. And then last one, if we put 3.5 over 1, it would be 1 and what? 3.5. 1, 2, 3.5. Somewhere like that. Okay. So that's not as important as maybe finding the unit rate, but it's important to understand the algebra piece of it, and that's what we're starting to dovetail into. Okay? All right, guys. So if I flip the page, we're going to look at this page. This is your homework tonight, 1 through 5, representing rates, and make sure that, first off, the guided practice is done. You did it with me, and 1 through 5 is due tomorrow. Okay, have a good day.